In this section of the course, we begin to formally introduce class inheritance and all topics related to the inheritance. This also involves discussion about object-oriented design and possible design solutions that class inheritance could provide us in different situations. This is our presentation. And we're going to start with a small example in which we have a function print, which is getting a function parameter, which is a pointer to a printer object. So printer object apparently is designed in such way that this is a pointer to an object like this. So we have some sort of object in memory, and it has a field named type. Okay, so there are some predefined types like a laser printer type, inkjet printer type, fax machine type, and when printer is constructed and initialized, apparently the rest of the application, which needs to distinguish different types of printers, will have to look at that specific type, and here we are using if-else construct to make a decision about what to do. Like apparently different job has to be done on laser printer and on all other types of printers that we have. Now this design looks a little bit suspicious, because you can imagine that these, if printer class is managing physical machinery, some kind of physical equipment, obviously these equipments have different properties, and if we store everything in one box, it may be the case that the fax machine does not need properties of the laser printer. So therefore it's almost like in this box we have most likely properties for the laser printer, properties for the inkjet printer, properties for the fax machine, and if tomorrow we're going to add new type, there's some other, like perhaps we're going to print into a file, okay, just choose some sort of like PDF format and write output into the file instead of physical devices, then we still have to add new properties to this box. So this looks very suspicious, because I suspect that it's just like this if-else set of statements is just a scratch on the surface of how much else has to be done in this single environment of this type of printer that supposed to satisfy all sorts of printing jobs and all destinations for printing. Okay, so this is just an outline of problems to solve potentially as we discussed it. So this print function that has to deal with the complexity of that big box printer definitely grows complex over time. Okay, so there's just like no way around it, because we just keep adding more and more and more. Yes, it can be split into multiple functions, but that's for now. We're not doing it just yet. We're just thinking about the problems, and we're suspecting that this area is going to grow bigger. Also, of course, multiple flag variables or types like this will have to force us to use if-else logic or a switch statement, doesn't matter, but some sort of control flow structures that have to rely on all sorts of variables. Only experienced veteran programmers begin to understand how it works. Okay, so what does this really mean? It means that we would like to hire new people, and new people want to be happy with an existing code base, but when they deal with pretty complex parts of the system, they become kind of frustrated. They're getting shy to ask too many questions, because they think that perhaps they don't understand something that everybody else understands, but the reality is that it's just a poor design, or something is amiss in this complexity. Okay, so there we go, and there could be more of these problems to solve. So this is just obvious, I think. So what do we need? We need to think about the design issues. What could be done to redesign it? This was just like first approach, okay? And now we're going to, like someone decided, oh, we're going to have a printer class. That's pretty good. We have object-oriented printer. We have an object that represents the printer, so we're in good shape. But it's not yet complete in terms of the possible improvements. So structured programming is relying, which equals, by the way, C programming. Structured programming relies on functions. Okay, so we have. So what we can do is we can say, okay, we understand that there's plenty of complexity here. So let's check the type as much as we have to, and then redistribute, delegate the work, the rest of the responsibilities, to the laser printer, to the print inkjet, and so forth. So we create functions, right? So we create additional functions, and this is structured programming. So structured programming is relying on the presence of all of these functions that call each other, and things become a little bit more structured. They become more maintainable, and they can be documented accordingly, and so forth. Now, problems yet to be solved. If-else still remains a complexity. Okay, so just having to maintain this if-else statement, potentially not just in this function but elsewhere, is still a lingering issue. Okay, the Boolean flag variables still haunt programmers. Okay, so there could be potentially, remember we spoke about the very likelihood that printer has all sorts of flags and little properties, and these properties kind of differ between different types of printers. So that problem did not get away. Basically, the box that the printer, all the properties that the printer has, still in place. So they're still kind of like stepping on each other's spots. It's still problematic in terms of how complex this printer could be. And also, there could be additional, like, because we call functions, we may have to provide additional parameters, and it's very likely that there could be different or long lists of parameters right here in these on the list of these functions. So that's another concern. And that's a general set of issues related to structured programming. It's okay. This is not the end of the world. It's just something to be aware of, and we're still thinking about the design. Next step, we call this step encapsulation. So then we say, okay, how about we encapsulate properties of different kinds of printing devices into a class. So class can have more of a distinct set of properties dedicated to the laser printer, to inkjet printer, and so forth. And statically, we maintain separate classes to keep track of all necessary attributes. So we just add some classes and say, okay, let's have these classes encapsulate some of the printer properties that should belong to laser, inkjet, and fax machine. Okay, so it's better, possibly, because we're moving maybe in the right direction, because individual classes can be a little easier to manage. When we work on, we can focus on specific areas of this application. But if-else continues to control the logic in the original print function. So that couldn't go away at all, because the type is the type, and this is where we have to detect what type we have, and then we can delegate work to other parts of the application. So now these classes have individual print functions that we can now specify what parameters to use, and they will be doing whatever used to be, all present in this big function print to begin with. So then we make this decision to change the idea that printer should be the base class for all other sorts of printers in the system. So what is the meaning of this? We consider this as a hierarchy of classes. So we realize that there is quite a bit of relationship between these classes, and something is unique for individual classes, but there's probably also a common base set of attributes and also maybe functions that could be shared, and these arrows here indicate that this is a common base, something that can be shared between all of these classes. So for example, if we create an instance of laser printer at runtime, the idea behind it is that we're going to create this laser printer, okay, and this will be an object, and we create this, and this is, by the way, like pointer to this specific type. So this is laser printer box, and because it says that we would like to have this relationship, that we would like to have laser printer design around the more generic, more abstract printer class that encapsulates properties common shared between all of them, the instance of the printer class will be constructed inside, okay, inside the box. So this is the idea. So at runtime, we create classes. We can create this relationship, okay, between the classes, but design these classes individually. But then at runtime, when we instantiate laser printer, it will have this type of arrangement that the base class right here will be contained within the outer box. So basically, it's sort of like the properties of the inner box are managed by the logic of this class, and the properties specific to the laser printer will be managed by the functionality of the laser printer box, which is this one, okay? And then the idea is also that when we create different types of these objects, which all derive from the base class, notice that the print function right here is not taking specific types of class pointers right here. Instead, it's taking in as a parameter pointer to the base class. And the idea under inheritance is that when we then say print and delegate print to a specific printer, what will be happening is that if we have different types of printers, okay, they will be handling the print function individually. So if it's a laser printer, its own function will be invoked to handle the printing. And if it's a fax machine, it will have its own version of the print function, which will be specific to the fax machine right here, right? So if this is a fax machine, so one time we pass pointer to the laser printer, the second time we will pass pointer to the fax machine to use it to print. And depending on the type of the derived class of these underlying classes, specifically the kind of the actual printer we're using right here, different types of functions, different functions will be invoked, and the process will be delegating the calls to functions specific to these boxes, right? So if this is the view, the new view of the system, then we can really focus on the design of these individual classes, on the design of the base, and also notice that the if-else statement is gone, because now we're going to use inheritance and polymorphic features available under inheritance, which will dispatch the print automatically without if else to to the version of the function specific to the kind of the object that this parameter receives every time the function is invoked. So once again, if we create a laser printer, right? So we create this object and we call function print and we pass address of this laser printer to this function, and we just use this pointer and we say print, and the call will be magically delegated to the function that belongs to the laser printer and will be able to handle the job specific to the laser printer. Okay, next time we instantiate this object and we pass address of this object as pointer to the printer parameter right here, and this time when we execute the same code, the call will be directed or dispatched to a completely different function which belongs to the fax machine. Now, how is this possible? Because both laser printer and fax machine right here both derive from the printer class. Then they both will have this box, right, that represents the base class, the printer class, right? So this is the copy of the printer inside the laser printer, and this is the copy of the base printer inside the fax machine with the same attributes. And therefore it's possible to pass printer type of pointer, because of course this pointer is pointing to basically to the inner part of this box. Okay, and this one also is basically reaching out to the inner part, and both have exact same part inside because they all derive from the same base. Okay, so this is really just to picture how things look like in memory under the scenario that we instantiate the laser printer and the fax machine. And so this is now the current design with inheritance in place includes the things that if we have something that we can share among all of these classes, it's going right here. If there's something unique for the laser or fax machine, we have perfect placement to store attributes specific to these types of printing equipment. Okay, so we're really kind of managing memory very effectively. And at the same time, we can have function which can accept pointer to both kinds, right, or all kinds of these derived specific types of printers that we want to maintain in the system, because they all share this common part, right? So this common part is still there, so therefore it's not a problem to pass pointer to that part to the same function. And from there, the magic happens without if else. We start printing, and all of a sudden the different versions of functions will be invoked very predictably with respect to which of these classes we're using.